All right, Kaylee. So there's a couple of things that I noticed. It looks like when it's a single number that you're factoring out as a GCF, looks like you're okay with that. It feels like you're doing that really well. When you're factoring trinomial and you're canceling, it looks like you're canceling the binomials that have been factored from the trinomial or so forth. You're doing that really well. So I wanna highlight those ones. So the first one that I want to highlight is right here. Question number two, you're doing it exactly right, right? So you're factoring out that trinomial, you're factoring out the GCF, which happens to be just a number, and then you're canceling out the binomials that are exactly the same. And I think that's important to recognize that makes sense. Where you're starting to falter though is on the factoring of GCFs that are including variables. So when you have a variable included in your GCF, that's where I'm seeing a little bit of problem. So for example, number one would be a good one. Number one, you have 4x to the power of 3 in the numerator. And in the denominator, you have 7x to the power of 2. Sorry, I think that might be a 14, so I'll write a 14 in there. 7x to the power of 2 minus 14x. So the 7x to the power of 2 minus 14x. What you want to do is you want to focus in on the number first, which you're doing really well. Like I said, they both can be divided by 7. So what I would do is I would say, okay, well, I know they can both be divided by 7, so I'm going to write 7. But then I also notice that this one here has two x's and this one here has a single x. That means if I wanted to, I have to divide both of them by the same amount. I can divide both of them by a single x. I can't divide this one by two x's, so I'm not going to. This one here I can, but remember, you must be able to. It must be common, right? You must be able to do it to both of them. So we can't do it to both of them. So what I'm going to do is I'm just going to factor out the common x, 7x. Now the next thing I'm about to write down, I wouldn't suggest writing down, but it might be helpful. So I'm going to try. But like I said, it's not something I generally condone. It does cause confusion with some people. So when you divide this by 7x, the question is, what is the result? And when you divide this by 7x, what's the result? This is going to help us out figure out what should be left in our factor. All right, so I'm going to set up my two parentheses. So when you divide this by 7x squared, notice the 7's cancel and the x squared cancel. This leaves you just x. Now if you go back and distribute, you'll notice that 7x times x does result in the front term right there. And the same thing is true here, minus. And when you divide these two things, you end up getting just 2. And that right there is how you're going to want to factor a common factor that has a variable involved with it. It's very similar to factoring numbers, except now you're talking about variables, which looks different, but the interactions are exactly the same. All right, so now that you have this thing here will not cancel with anything on the top because nothing on the top is a binomial. That's a key right there. That's important to understand. I'll show you what I'm talking about in your problem number 3. So this right here is going to stay. But however, this guy, this is kind of cool right here. This is a monomial and this is a monomial. What that means is those things can simplify. So the 7 and the 14 can cancel like a normal fraction would cancel. So we're going to have a 2 on the top. And then you'll notice that you have 3 x's on the top and an x on the bottom. When they cancel, you're going to go down from having 3 x's to having 2 x's because the one down here is going to cancel out with one of those up there. And then now you're going to want to simplify it. So now what we have is 2x to the power of 2. So I'm going to write 2x to the power of 2 over x minus 2. All right, and that's the answer that we're looking for. Now, I will say that for problem number 1, I think I made a mistake in the answers, and I did fix that, so it is fixed now. But I don't think I included this as one of the options. A lot of people that did the problem correct, though, before I had corrected it, had the one where there was no x there, because that was the closest image. Okay, now let's move on to problem number 3, and that's where I'm going to address my last issue. I might address it over here as well. But when you're factoring here, this looks okay. You definitely get the number. Like I said, your numbers are good. So you'll notice that this number here and this number here can both be divided by 4. Now, how many x's can you take out? And I'm going to say you can take 3 here and 2 here, but you got to take what's in common. So you can take 2 from both of them. So I'm going to write down that it's 4 and then 2 x's, 4x to the power of 2 times. And then now right here, when I divide, that's going to leave me with a single x. Because if I was to multiply that, it would result in the original first term. And then the question is, what do I need to multiply the 4x squared by to get the 12x squared? And that would just be an x plus 3. So I'm going to go ahead and factor that out right there. And I'll do the same thing for the denominator. Both can be divided by 6. They also have in common x squared and an x. I can only take as much as the one with the least is willing to give. So what do they have in common? They have a single x in common. This guy has two x's, right? It has x and it has an x to the power of 2, but they only have a single x in common because this guy only has an x. So I'm going to write 6x right there, and then the result would be x plus 2. X plus 2. All right. And then, now this guy here can only cancel with other binomials that are exactly the same. And you'll notice that these two binomials are not the same. They are different, okay? So these two binomials are different from each other. They're not the same. They're not going to be able to cancel out. You can't even cancel their x's because it's the entire binomial that must be the same. So we do know for a fact at least x plus 3 and x plus 2 are going to be part of the solution set. The question is, what is the rest of the simplified version of this fraction? Next, I'm going to cancel out the numbers, right? So this is a monomial, and this is a monomial, and we're allowed to cancel monomials, partials, pieces of them. So this is going to cancel out here, and that's going to give me a 2 and a 3, because they both can be divided by 2. And then there are two x's on the top, one x on the bottom. The one x on the bottom is going to cancel with one of the x's on the top, and the result is going to be 2x and 3. So my final answer is going to be this right here. I know it's really hard not to cancel those 3's, but remember, the more you do this, the more you're going to start to realize that if it's not the same exact size, right? This is a binomial, 2 pieces, and this is a monomial, they're not going to cancel. So if they're not the same size, you can't cancel them. Whereas these ones were both monomials, they were both single terms, they can cancel. Whereas these ones, both binomials, if they were exactly the same, they would cancel. And then I'll take a look at number 4 just real quickly, some things I noticed. The x plus 5, those are different, right? So that's x plus 5x. Now, I'm pretty sure that the factoring is incorrect here, and that might be part of why the problem or the answer is wrong. So I would go back and refactor this. The top looks good. Your bottom, once again, it's that x. The variable is where you're having trouble, so focus on that variable. But what I do want to address is this. So if you have x minus 2 over 2x, like you have, I'm not saying this is the right answer, I'm just saying what if you had that? That would be it. You can't factor anything, you can't cancel anything. You can't cancel the x's, and it has to do with the fact that this is a binomial and this is a monomial. Monomials can cancel monomials, right? And not parts of the binomial, but monomials. So these guys have no way of interacting with each other. This right here would have been our answer if everything that came before it is correct. Now everything that did come before it's a little hazy, so I don't want to say it's right or I don't want to say that this is correct. You'd have to go back and check this. I'm going to say that it looks like it's right. This is not looking so good right here, so you'd want to fix that. And then finally, number 5 is perfect, right? So once again, anytime you have to factor out a number, looks like you're doing it perfectly. It's when you have to factor out the variable when things start to fall apart. So that's something that you might want to practice. To give you an example of a problem where you'd see something like that would be something along the lines of, let's say, 48 x to the power, let's make it a little more complicated, x to the power of 7 minus, let's go with 20, no, not 24, let's just do 20. 20 x to the power of 5. So if I ask you to simplify, if I ask you to factor that, how would you factor it? Notice it's not a rational, so it's not a fraction. I just want to focus on this part that you're having a trouble with, and it's the factoring piece. What do they have in common, and so forth. So if you wouldn't mind taking a look at that problem, sending me an email on what you think, how you would approach that answer. If you want to take a picture and just send me a picture, that's fine. If you have any other questions, please let me know. Thank you for commenting and let me know that you're having some trouble with this. If you think your sisters are having problems with this, you might want to let them take a look at this as well, and then they can comment as well. All right, I hope everything is going well, and I hope to be talking to you guys soon. Bye.